Okay guys, Professor Hildebrandt here. I am going to work through just some of the problems from the Unit 2, let's just say Unit 2, the Unit 2 Course 10 exercise. I'm not going to go over all the questions, especially those on like the Against All Odds videos. I feel like y'all can figure those out, but I'm basically going to work the math problems on the probabilities and the probability distributions. So here we go. The first question, the following table depicts the number of children per family in a neighborhood in Carrollton, and then the share of the families with that number of children, or the probability, right? So 0.3 is 30% of those families have one child. So we're asked to find the expected value or the mean number of children. And so this is simply where we sum up. We take each of the X values, we multiply it times its probability of occurring, and then we add all of those up, okay? So 0 times 0.1 is 0. 1 times 0.3 is 0.3. 2 times 0.4 is 0.8. 3 times 0.1 is 0.3. 8 times 0.06 is 0.48. And 9 times 0.04 is 0.36. So those are all of that. And then we just sum it up, and we would get 2.24. Okay. And we were asked, the rounding on these was all to the thousands position. So our answer here would be 2.240. Now keep in mind, if you're looking back, and I did adjust the view so you guys can see all of the questions, your answers, and the correct answers, okay? But most of these problems, actually I think all of the ones I'm going over are algorithmic, so your numbers and therefore your answer are different, most likely, but the methodology is the same. Okay, so let's move on to the second question. So assume the probability of a defective part coming from a production process is 0.27. So you're given the probability. It's basically a 27% chance, okay? Assume that the probabilities that each part is defective are independent of the other. So what that means, if one is defective, it has no impact on the probability of whether the next one will be defective also. But we want to know the probability that the next 3 parts produced are all defective. So this is where we use that rule of multiplication. And so it's simply the same probability for each. So for the first, there's a 0.27 chance that it's defective. For the second, there's a 0.27 chance. And for the third, there's also a 0.27 chance. And so you would get an answer of 0.01968 on and on and on your calculator. But recall, we were asked to round to the thousandths position. So once we do that, my answer here is 0.020. Next up, suppose you're an investor and you've heard that Amazon is going to open one new headquarter somewhere in the US, and you're given the probabilities. And then you're asked to find the probability that it either opens in Chicago or LA. Okay, let me back up 1 second here. I think one of the things that confused some of you was a lot of these questions in this assignment gave you the probabilities, right? The one I just worked, it told you the probability was 27%. Here it's telling you the probabilities. So some of the questions, part of the first step is basically done for you, is what I'm saying. So don't overthink these, okay? So here we're trying to find the probability that the plant we open is in Chicago, or the probability that it's in LA. So we just take those individual probabilities and we add them together. So the probability of Chicago is 0.243. The probability for LA is 0.387. And so that gives us a probability of 0.630. And that is my answer for this question. All right, a few more to go. There's 30 students in a stats class. 13 are male and 17 are female. On the first exam, 4 males had an A, 5 females received an A. What is the probability that a student chosen at random earned an A on the first exam or is female? So these categories are not mutually exclusive. There is some overlap. So here what we have to do, we're going to find the probability that a student makes an A on the exam. We're going to add that to the probability that the student randomly selected is female. But then to get rid of the overlap, we have to subtract out the probability that the student was both female and they made an A on the exam, okay? Now, remember, we're taking this out of a total class of 30. So all of my probabilities down here for these classical probabilities are all out of 30 total students. Okay, so the probability that the students made an A, well, there was 9 total students out of 30 that made an A. There are 17 females in the class, but there are 5 females who made an A, so they're in both categories. This gives us 21 over 30, or 0.700 for our answer here. All right. Got 3 more that I'm going to go through, and then I'll wrap this up. We've got a College of Business with 57 in-state students and 15 out-of-state. So the total number of students is 72. We decide to randomly select 3 to serve as our representatives, and we want to know the probability that all 3 students that we select to serve on this committee are all in-state. So again, we're going to use that rule of multiplication. So there's 57 in-state out of 72. So for the first student drawn, it's 57 out of 72. Now that student's drawn. So now there's only 71 students left to pick from, 56 of which would be in-state. And now there's 55 left out of 70. And so when we get this, we'll have these really big numbers. Here's our numbers here. And then when we divide it out, though, you'll get an answer of 0.491, or about a 50% chance that all 3 would. Because look at those numbers. The majority of the students in this college happen to be in-state. Okay, so the last 2 questions that I'm going to work for you were contingency tables. So the first thing I will say on the exam or when you're working questions, if your contingency table is what I'm about to call not complete, go ahead and complete that. That's going to help you think through how to solve these questions, okay? So what do I mean by that? The totals, right, are not tallied up yet. So I'm going to do that. How many total fatalities did we have? Well, there was 18. 1 in a house that had a smoke detector and 17 that did not. How many total no fatalities did we have? Well, that was 34, right? And then we'll go down this way, down the columns. How many total homes had smoke detectors? 20. How many total homes did not have smoke detectors? 32. And all in all, we're looking at 52 different cases here. So now to the question. Based on the following contingency table, what is the probability of having a fire with no fatalities? Okay. And so this contingency table is all the home fires. So all of the fires were 52, my total. Okay. All of them were 52. Well, how many ended with no fatalities? Well, that total is 34. So y'all, it's just a basic classical probability of 34 over 52, or my answer here is 0.654, okay? Next one, this is similar, it's the same kind of thing. We're still looking at all home fires. Yes, my numbers changed. Why? Because these problems are algorithmic. And so I hope you didn't just assume your number stayed the same. Again, I'm going to first start by tallying up everything here to help me clearly see my picture before I even look at the question. Okay, so again, I just totaled down these columns and across these columns. Okay. All right, so now we're looking, given that there was a smoke detector in the home. That means, you guys, we are only looking at this first column here with a smoke detector. So given that there was a smoke detector in the home, what's the probability of having a fire with no fatalities, which is the 20? Okay, so the total number of houses that had a fire with a smoke detector were 29. The total that had no fatalities were 20. Again, my numbers for this example. And so the answer here is 0.690. Okay, so I hope that this helps. Again, don't remember that uniform distribution will also be covered on the exam, but those are really straightforward. And I did list some problems for you to work from the chapter on that concept. But if you have any more questions before the exam, you guys please send me an email or a text.